Hey ladies and gentlemen, this is Miss Humbert here. Today we're going to be doing Unit 7, Notes 3. So we're going to be talking about combinations, which is very similar to what we did with permutations, but this time the order is not going to matter. So let's go ahead and let's start by taking a look at this. The basketball league has 5 teams, okay? So 2 of these teams are chosen to play, and now how many different matchups are there possible? So let's call the teams A, B, C, D, and E. I know, really super creative names. So Team A could play Team B, Team A could play Team C, Team A could play Team D, or Team A could play Team E. Now, the key thing to remember is that if Team A plays Team B, that's the same as Team B playing Team A. So the reverse of those really means the same thing, so order doesn't matter. So I don't need to write BA because it's already included in AB. But Team B could play Team C, Team B could play Team D, Team B could play Team E. Likewise, C could play D, C could play E, and finally D could play E. So that represents all of our different combinations of the ways a team can play. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay? So let's go ahead and let's just briefly talk about what combinations are. First and foremost, a combination is an arrangement or listing of objects in which order is not important. And that's the key thing right there, is that the order of these things does not matter. So here is that formula for combinations. So you're going to do n choose r, and that's going to be equal to n factorial over n minus r factorial times r factorial. Okay, so that's going to be the formula that we use today. So let's go ahead and let's take a look at 6 choose 2. So we're just going to practice putting this in the formula. So I'm going to have 6 factorial divided by 6 minus 2 factorial. Now notice that I'm putting that in parentheses, times 2 factorial. So I have 6 factorial divided by 4 factorial times 2 factorial. So everything from 4 on down is going to be taken care of in that 6. So I like to take whatever my biggest factorial is on the bottom. My biggest factorial on the bottom is 4. So what I'm going to do is I'm going to cancel out as much of 6 as I can. So I actually can get it down to just be 6 times 5, because 4 times 3 times 2 times 1 is going to be taken care of there. Then I'm going to divide by 2 factorial, which is 2 times 1. So 6 times 5 is 30, and 2 times 1 is 2. 30 divided by 2 is 15, or 6 choose 2. So that's going to be 15. Now, let's go ahead and let's take a look at this next one. So we're doing 8 choose 3. So we're going to do 8 factorial divided by 8 minus 3 factorial times 3 factorial. So then we're going to do 8 factorial on top. 8 minus 3 is going to be 5 factorial, and then we're going to have 3 factorial. So then I want to take a look. My largest factorial on the bottom is 5. So that's what I'm going to use to take out of the 8. So 8 times 7 times 6 times is what's going to be left on top, because everything else is going to be taken care of in the 5 factorial, everything from 5 on down. Then left on the bottom, I just have 3 times 2 times 1. So now I'm going to multiply that out. 8 times 7 times 6 is going to be 336. 3 times 2 times 1 is just going to be 6. And you take and you can divide those out, and you end up getting 56. So let's go ahead and let's take a look at this right here. It says a group of 7 seniors, 5 juniors, and 4 sophomores have volunteered to be peer tutors. Mr. Bakar needs to choose 12 students out of the group. How many different ways can he choose 12 students? Well, if you think about it, it doesn't matter what order he chooses 12 students. It just matters simply that he chooses 12 students. So if you count 7 plus 5 plus 4, you find out that there's a total of 16 students that are eligible. That's always going to go on the left side of my combination. So you have 16, and you're going to choose 12 of them. So let's go ahead and let's calculate that out. So we have 16 factorial, and then we're going to divide that by 16 minus 12 factorial, and then that's also going to be multiplied by 12 factorial. This factorial right here is what makes it different than a permutations formula. So then I have 16 factorial. 16 minus 12 factorial is 4 factorial, and then I have 12 factorial. So I can take out 12. That's my larger x, my larger factorial. So I can take everything from 12 on down out of that 16 factorial. So on top, I have 16 times 15 times 14 times 13. Then on the bottom, I also have 4 factorial, which is 4 times 3 times 2 times 1. So then what I'm going to do is multiply out the top. So when I multiply out that top piece, I get 43,680. And then when I multiply out the bottom, I end up getting 24. So when you divide that out, you end up getting 1,820, and then you're going to write ways, because that's how many ways Mr. Picard can choose 12 students out of 16. Let's go ahead and let's take a look at this next one. It says you and 6 friends are going to eat lunch. You can only take 2 people with you. How many different combinations of people can ride with you? So it really doesn't matter the order in which you choose to bring people. It just matters the people that you choose to bring. So you have 6 total friends that you are choosing from, but you're only going to take 2 of them. So let's go ahead and set that up in combinations. So you have 6 factorial, and then you're dividing that by 6 minus 2 factorial times 2 factorial. So then I have 6 factorial divided by 4 factorial times 2 factorial. So here's the larger factorial here. So I can actually take that out of the 6 factorial. So everything from 4 on down is going to be taken out of that. So I have 6 times 5 on top and 2 times 1 on the bottom. So I end up getting 30 divided by 2, which is going to give me 15 different ways that you can go about doing bringing friends with you in the car. Okay. So let's take a look at this next one. It says that a gym coach selects a team of 4 athletes from 14 athletes to represent the school at the track and field meet. Find the number of teams the coaches could make. Now, to me, the word teams implies that there's not really an order to anything. We're just looking for a group of 4 athletes to take. So to start off with, we have 14 total athletes, and we're going to choose a group of 4 of them. So what we're going to do is we are going to take the 14, and that's going to go on top. And then on the bottom, we're going to have 14 minus 4 factorial, and then we're also going to have 4 factorial. So then on top, we're going to have 14 factorial. 14 minus 4 is 10 factorial, and then we have 4 factorial. So 10 is the larger factorial. So everything from 10 on down is going to be taken care of. So left up top, we have 14 times 13 times 12 times 11, and everything else from 10 on down is going to be taken care of here. So then left over, I have 4 times 3 times 2 times 1. Well, when I multiply out 14 times 13 times 12 times 11, I end up getting 24,024. 4 times 3 times 2 times 1 is going to be 24. So I divide that out, and I end up getting 1,001 different ways. So that's the number of ways that you can select your track team. Next, now we need to start deciding when do we use permutations and when do we use combinations. So we need to determine which is which. So first, let's just read it. So it says, a subway car has 8 empty seats. At one stop, 5 people enter the car and no one gets off. How many ways can 5 people arrange themselves in the 8 empty seats? Now, whenever you see the word arrange, that should instantly tell you that it's a permutation. Arrange implies that there's some sort of order. So that means that we have to use permutation. So we have a total of 8 empty seats, and we're picking 5 of them. So let's go ahead and let's take a look. At top, we're going to do 8 factorial. And then on the bottom, we're going to subtract and do 8 minus 5 factorial. Okay? So when we do the permutations formula, remember we don't have that extra factorial on the bottom. So this is simply going to be 8 factorial minus 3 factorial. So everything from 3 on down is going to be taken care of. So I'm going to have 8 times 7 times 6 times 5 times 4. And then I'm going to go through and I'm going to multiply all of that out. Okay, so when I do that, 8 times 7 times 6 times 5 times 4, I end up getting 6,720 different ways that they can arrange themselves in those seats. Now let's take a look at this one. A history test lists the name of 5 presidents, and each student is chosen to compare 2 of them in an essay. how many different pairings are there? Well, think about it this way. If you compare Abraham Lincoln to Thomas Jefferson, is that the same as comparing Thomas Jefferson to Abraham Lincoln? Well, yeah, it is. So the order in which you pair them doesn't really matter because ultimately you're just comparing the two. So that's going to be a combination. So you have 5 total and you're going to choose 2 of them. So we're going to have 5 factorial on top, and then on the bottom we're going to do 5 minus 2 factorial as well as having 2 factorial. So we're going to have 5 factorial, 5 minus 2 is 3 factorial, and then you're going to have 2 factorial. So let's start by finding the larger factorial on the bottom, and that's going to be this 3. So everything from 3 on down in that 5 factorial is going to be taken care of. So I'm just going to have 5 times 4 left on top, and then on the bottom just 2 times 1. Well, 5 times 4 is 20, and 2 times 1 is 2. 20 divided by 2 is 10 ways. So there's 10 different ways that you can arrange that. Okay? Pick those pairings. I don't want to say arrange because that implies order. So let's take a look at number 8. A survey asked people to rank basketball, baseball, tennis, soccer, and football according to how much they enjoy watching each sport. How many possible responses are there? Rank is another word that definitely should indicate to you that there's some sort of order. First place is definitely different than last place. Okay, so we have 1, 2, 3, 4, 5 different options, and we're actually going to order all 5 of them. So we're going to have 5p5. So up top, we're going to have 5 factorial. Then on the bottom, we're going to have 5 minus 5 factorial. So then what we end up getting is 5 factorial over 0 factorial. So please, allow me to give you a little fun fact that will probably blow your mind, and you're just going to be thinking about it all day. Okay, 0 factorial is equal to 1, okay? 0 factorial is equal to 1. So really, this is just 5 factorial. And 5 factorial is 5 times 4 times 3 times 2 times 1. And when you multiply all of those out, you end up getting 120 different ways that you can rank all of those sports. All right? Next, let's go ahead and let's take a look at number 10. There are 20 students in speech club. 3 of these students will be chosen to represent the school at the regional competition. How many different groups of the 3 students can be chosen? Typically, when it says groups, that implies a combination. The word group typically tells you you're just kind of taking a whole mass of people, and it doesn't matter which order you take them in. So this one in particular is going to be a combination. So we're going to start, and we have 20 students, and we're going to choose only 3 of them. So I'm going to have 20 factorial divided by 20 minus 3 factorial times 3 factorial. So then I get 20 factorial divided by 17 factorial times 3 factorial. So my largest factorial on the bottom is 17. So everything from 17 on down in that 20 factorial is going to be taken care of. So on top I have 20 times 19 times 18. On the bottom, 3 times 2 times 1. So when you multiply out 20 times 19 times 18, you end up getting 6,840. 3 times 2 times 1 is 6. Divide them out and you get 1,140 ways. Okay? So, next, take a look at this one. How many different ways can the letters in the word combination be arranged? There's that key word again that you're looking for, that arranged. That tells you that there's some sort of order, so you need to use a permutation. So what we want to do is calculate how many letters we have in combination. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So on top, I'm going to have 11 factorial. Now I need to divide to account for any letters that are being repeated. Well, I notice that I have 2 O's. I have an O here, and I have an O here, so I need to divide by 2 factorial. I have 2 I's, so I need to divide by 2 factorial again, and I have 2 N's, so I need to divide by 2 factorial. So then I get 11 factorial divided by 2 factorial, 2 factorial, 2 factorial. I really don't need to just rewrite that out again. So 11 factorial, that's 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you type that into your calculator, you get this huge long number here. 39,916,800. Then we're dividing that by 2 factorial times 2 factorial times 2 factorial, which is really just 2 times 2 times 2. So that's going to be 8. So when you divide that out, you end up getting 4,989,600 different ways that you can arrange the words in combination. So that concludes your note video for today. Thanks for listening.